Welcome back, Algebra 2 students, to another Regents review video. This is the Algebra 2 Common Core exam for January 2017. Here we go. These are going to be the solutions to Part 1, questions 1 through 12 of this exam. All right, before we begin, as usual, do not take my answers and call them your own and cheat. It's not okay. Not okay, because Algebra 2 is a hard class, and it's a hard Regents. Make sure to hit that subscribe button down below. It could help me out a lot. Consider becoming a patron on my Patreon page. I would greatly appreciate your support if you do decide to do that. And visit my website at www.nysmathregentsprep.com. And I also use the TI Inspire CX calculator. That link could also be found on my website. Links you right to Amazon. It is one powerful tool. And without further ado, let's begin. Starting off with number 13. And we start off with not an easy question, but not a hard question. Kind of midway through. Here we go. The price of a postage stamp in the years since the end of World War I is shown in the scatter plot below. Okay, fine. Then it says the equation that best models the price in cents of a postage stamp based on these data is what? So here's the thing. We know that this is an exponential graph, okay? So we could get rid of anything that's not an exponential graph. So we can get rid of a line because this is not a linear graph, and it's not a sine curve because it's not cyclic. It's not cycling through, and it's not linear. So we definitely know it's exponential, okay? So if we look here, we're basically just looking at the rate of increase. So the best thing to do in your shoes is to graph these two functions on your graphing calculator from 0 to 100 and 0 to 60. Let me explain what I mean by that. If you go to your graphing calculator and you go to Menu, Windows Zoom, Windows Settings, you want to force it to be from x equals 0 to 100 and the y values of 0 to 60. Ignore the autos for a second. It really doesn't matter. Oh, I'm sorry. The y-min is -10. My apologies. All right, click on that. And we have our scale that's necessary that actually fits what's given to us. So I'm going to graph 1.04 times 1.43 raised to the x power. And I'm going to graph 1.43 times 1.04 raised to the x power. Which one looks like the picture on our graph? Obviously, it's the red one because I just fit it into the window that they gave us. Your answer is choice 3 for that question. That's how you do it. You just narrow down the choices by using a graph, and you know it's not linear, it's not cyclic, so it has to be an exponential function. Number 14. The 8th and 10th term of a sequence are 64 and 100. If the sequence is either arithmetic or geometric, the 9th term cannot be what? Okay. So I found this, I love this question because I'm such a nerd, but I like this question a lot because it's really testing your knowledge on whether or not you understand the difference between arithmetic and geometric. So this is going to be a sub 8, this is going to be a sub 9, this is going to be a sub 10. Okay. They give you the 8th term, it's 64. They give you the 10th term, which is 100. Your goal is to find the middle term. Now, what if this term, or what if this sequence was arithmetic? Well, you need to find the common difference. And most teachers teach it differently. I teach it this way, okay? How do you get from 64 to 100 by adding a common difference? Well, to get from a sub 8 to a sub 9, you add by a common difference of d, whatever that d value is. Then to get from 9 to 10, you add by a common difference of d. Okay, so to solve for the common difference, you take your 64, add 2 d's, and you get 100. This will allow you to solve for the common difference. So subtract the 64 on both sides. You get 2d is equal to 36. Divide by 2 on both sides. The common difference is 18 if you were to do it arithmetically, okay? So therefore, the a sub 9 term, if the common difference was 18 and if it was arithmetic, the a sub 9 term would be 64 plus 18, which would be 82. Okay? So 82 is, in fact, achievable to get that answer. So now forget about arithmetic for a second. Now let's figure out geometric. Well, now geometric is a little different. Remember, arithmetic, we're adding. Geometric, we're multiplying. So this time, we're actually going from a sub 8 to a sub 9. We're multiplying by the common ratio r. Then from a sub 9 to a sub 10, we're multiplying the common ratio of r. So 64r squared equals 100. What did I do? I took the 64, I multiplied those two r's together, got r squared, set it equal to 100. You could solve for your common ratio. Divide by the 64 on both sides. We get r squared is equal to 25 over 16. No, sorry. 100 over 64. I just skipped a step there. My apologies. Now you take the square root of both sides, and you get no, I'm right. I was right before. 25 over 16. Now take the square root of both sides, and you get r is equal to plus or minus 5/4. Ladies and gentlemen, this is the common ratio, plus or minus 5/4. So this answer, a sub 9, could be two different answers under the geometric sequence. Okay? What we need to do is take 64 and multiply it by positive 5/4 and negative 5/4. So a sub 9 could be 80, or it could be negative 80. So it could be any one of those two answers for geometric. So the only answer that does not work in this case would be, let's see, 82, 80, negative 80. Your answer is negative 82. That cannot result from this information, okay? And that's how you do that question. Moving on to number 15. I don't like this one. The loudness of sound is measured in units called decibels. These units are measured by first assigning an intensity I sub 0 to a very soft sound that is called the threshold sound. The sound to be measured is assigned an intensity I, and the decibel rating D of this sound is found by using D equals 10 log I divided by I sub 0. Okay. The threshold sound audible to the average person is 1.0 times 10 to the negative 12th W per m squared, watts per square meter. Consider the following sound level classifications. How would the sound with intensity 6.3 times 10 to the negative third be classified? Wow. So I think that this question is so easy yet so hard at the same time, just because of all this freaking words and symbols and whatever. Anyway, so 6.3, okay? 6.3 times 10 to the negative third. This is the assigned intensity, okay? It's assigned. They tell us what it is, okay? So we're going to use D equals 10 log of I divided by I sub 0 to get this right. So D equals 10 log. Now, the I, because capital I is the assigned intensity, okay? The assigned intensity is 6.3 times 10 to the negative third, divided by now I sub 0. What does it say? I sub 0 is assigning a soft sound. Well, the soft sound is what's audible to humans. A person can listen to 1.0 times 10 to the negative 12th sound. So that's your I sub O, or I sub 0, I should say. 1.0 times 10 to the negative 12th. What you're going to do is you're going to type this into your calculator and see what you get. Okay? Control division. Nope, got to put a log out front. 10 log. Control division. 6.3. What am I doing? 6.3 times 10 to the negative third. And 1 times 10 to the negative 12th power. Get that answer, 97.99. So D equals 97.99. On the scale, that would be considered very loud. 97.99 is in here. Your answer is choice 3, very loud. Okay, number 16. Pedro and Bobby each own an ant farm. Pedro starts with 100 ants and says his farm grows exponentially at a rate of 15% per month. Bobby starts with 350 ants and says that his farm is steadily decreasing by 5 ants per month. Assuming both boys are accurate in describing the population of ant farms, after how many months will they both have approximately the same number of ants? So, what we got to do is we got to figure out two equations. We need to find Pedro's equation, and we need to find what's the other? Bobby's equation. Okay? Pedro's equation is exponential growth. Okay? It's growing exponentially. So, exponential growth is modeled, remember, by a of t is equal to the principal times 1 plus or minus a rate raised to the t power. So in this case, we have, now I'm actually going to call his letter P for Pedro. So P of t is equal to the principal. He started off with 100 ants. And he's saying it's increasing by 15% per month. So that's 1.15. Raise it to the t power. This is Pedro's equation. And Bobby's equation, he says it's decreasing steadily by 5 ants a month. So that means that his is a it is a linear function. Okay, so b of t, or y equals. So his is going to be, he starts off with 350 ants, and he's subtracting 5 ants per month. So this is Bobby's equation. So it's an exponential function and a line. So what we're going to do is we're going to go to our graphing calculator, and we're going to find the point of intersection. Here we go. Make sure you type in an X into the calculator because it doesn't recognize T. Okay, now you can't see it. So what you're going to do is you're going to go to Menu. You're going to go to Windows Zoom, Zoom Fit, and it fits it for, oh, beautiful. They even show you the intersection point. So click on Menu, Analyze Graph, Intersection. Click Before, then After. Your intersection point is 8.09, 310. So about after 8 months, they will have approximately the same number of ants. So your answer is choice 2 for that question. All right, moving along to number 17. What is the solution, if any, of the equation of that? Okay, so what we need to do first is we need to find ourselves a least common denominator. Now remember, a least common denominator is what's common between everything. Okay, I'm going to factor this real quick. The factor of x squared minus x minus 12 is x minus 4, x plus 3. Okay, this is x plus 3, and this is 4 minus x. So the least common denominator, and I know it's going to bother some of you, the least common denominator is actually just x minus 4, x plus 3. So what your goal is now is to make every denominator look like x minus 4, x plus 3. Okay? So how do we do it? Well, I'll show you. You only multiply the fractions by what you need. So you need, on this fraction, you need an x minus 4 on both the top and the bottom. What you do to the bottom, you must do to the top. So we get this, right? Then, we have 4 minus x. Ladies and gentlemen, subtraction is not commutative. 4 minus x is not the same thing as x minus 4. So you actually need one more thing here. You need to multiply by x plus 3, and you need to multiply by a negative 1 to fix this. That has to be x minus 4, not 4 minus x. So you need to multiply that by a negative 1. And what you do to the bottom, you must do to the top. And this stays the same. We don't need anything. So now we get 2 times x minus 4 all over x plus 3, x minus 4, plus a negative 3 times x plus 3 all over x plus 3, x minus 4 is equal to 2x minus 2 all over x plus 3, x minus 4. When you get the like denominators, cancel all those out, set the top equal to each other, and solve. So we get 2 times x minus 4 minus 3 times x plus 3 equals 2x minus 2. I'm going to distribute on in. Okay, so we get 2x minus 8, oops, not equals, minus 3x minus 9 equals 2x minus 2. Okay, let's go and solve for x. So I'm going to combine like terms. I get negative x minus 17 equals 2x minus 2. I am then going to add that x on both sides. I'm going to add that 2 over. So we get negative 15 equals 3x. Divide by 3 on both sides. What did I do here? Hold on 1 second. I don't like what I just did. 2x minus 8 plus... Didn't I make that? Hold on a second. Plus... Oh, I'm sorry. Wait a minute. Oh man, I was not careful. Look at this. Negative times a negative gives you a positive. I don't know why I made that negative. My apologies. That should be a positive number. That's why it wasn't looking good for me. So these should be positive answers. Positive numbers right there. We go. That's better. So we get, oh, that changes everything. So 5x plus 1 equals 2x minus 2. Subtract the 2x. Subtract the 1. We get 3x equals negative 3. Divide by the 3. And you get x equals negative 1. Make sure that negative 1 does work. If you plug it back into the denominator, it should not be undefined. And if you plug negative 1 back in, everything checks out. Your answer is choice 1. Everything works. Nice and easy. All right, number 18. In 2013, approximately 1.6 million students took the critical reading portion of the SAT exam. The mean score, the modal score, and the standard deviation were calculated to be 496, 430, and 115 respectively. Which interval reflects the 95% of the critical reading scores? So you need to know this. The 95% level is the mean plus or minus 2 standard deviations. Well, the mean is 496. So it's 496 plus or minus 2 times the standard deviation to tell you that the standard deviation is 115. So it's 2 times 115. Okay? When you simplify that, that's 496 plus or minus 2 times 115 is 230. And that, ladies and gentlemen, is your interval. Your answer is choice 4 for that question. That's all you got to do. Pretty simple stuff. Number 19. Which statement regarding the graphs of the functions below is untrue? I don't like that they said untrue. It's just say not true. Okay. So, let's go through these slowly. So, f of x equals 3. All right. They give us everything. Whatever. Let's take a look at choice 1. F of x and j of x have a maximum y value of 3. So let's go ahead and graph f of x and j of x. Okay. So I don't want geometry. So we get 3 sine of 2x. Graph that. And j. Negative absolute value of 4x minus 2 plus 3. Okay. Let's take a look here. So I'm going to zoom in. Actually, I'm going to change. Yeah, I'm going to make this 0. Going to make that 4. Gonna make that 2. And we're gonna make this 0 over here. Okay, so what I did is I just zoomed in closely into our graph. So I'm gonna click on menu, analyze graph maximum. Click on the red function first, click. Look at that. The maximum value is y equals 3. And click on menu, analyze graph non-intersection, my apologies. Menu, analyze graph maximum. Click on the blue function, click, and the maximum value is also 3. So the y values are 3. That is absolutely 100% true. So that, get rid of it. Now, f of x, h of x, and j of x have one y-intercept. So I'm going to zoom out here. I just graphed f of x and j of x. So I'm just going to zoom out. Okay? So they both do have one y-intercept here and here. So far that's good. Let's go ahead and graph h of x. H of x is log base 2 of x. Log base 2 of x. I'm going to change the color just so you can see it a little bit better and make it green. Okay? So we have this. Does this have a y-intercept? It does not, folks. You see, a log function, all right? A log function never intersects the y-axis because there is a vertical asymptote of x equals 0 at this location. The reason why a log can't be negative, so it has to have an asymptote somewhere. So it has to be greater than, so x has to be greater than 0. So that is actually false because a log function, logs do not cross the y-axis unless there's a horizontal shift. Then everything changes. But a log that looks like that does not cross the y-axis. Your answer is choice 2. Choices 3 and 4, those are both correct. They have rational zeros, meaning that you could express the number as the division of two integers, and g of x and j of x have the same end behavior as x approaches negative infinity. That is true. Number 20, when g of x is divided by x plus 4, the remainder is 0. Given that g of x is equal to that thing, what conclusion about g of x is true? Oh my goodness, this is like the 4th time I've seen this, something like this. You need to know the remainder theorem. The remainder theorem, okay? The remainder theorem states that if you take the factor of x plus 4 and you set it equal to 0, you get x equals negative 4, okay? X equals negative 4 is a root of g of x, okay? So if you take negative 4 and you plug it into g of x, your output has to be 0. Because if they're telling you that x plus 4 is a factor and the remainder is 0, therefore, g of negative 4 must equal 0. And that is strictly by the remainder theorem. What this notation is saying is this. When x equals negative 4 is inputted into g of x, the result is 0. And that is true by the remainder theorem. Okay? Not a bad question. And make sure you understand what the remainder theorem is because it's on almost every exam. Number 21. Jolie has a credit card that has a 19.2% annual interest rate, compounded monthly. She owes a total balance of $B after M months. Assuming she makes no payments on her account, the table below illustrates the balance she owes after M months. I swear, these poor people on the Regents exams, they put people who have bad credit. If you're not paying your credit card after 73 months, you shouldn't have a credit card. You shouldn't even have a bank account. Over which interval of time is her average rate of change on the balance of her credit card the greatest? So we're looking for where is the slope the greatest? Okay, I am going to do this very quickly, and I'm going to write down all of the slopes that you would get. So the change in y over the change in x from the 10th month to the 60th month, I'll just write that out for you. That's 2591.90 minus 1172 divided by 60 minus 10. That is approximately 28.4%. Okay, that is the slope. Choice 2, again, change in y over change in x, that's 2990 minus 1352 divided by 69 minus 19. That will give you 32.8%. That's the slope. Choice 3, that is going to be 3135.80 minus 1770.8 divided by 72 minus 36. That percentage is 37.9%. And choice 4 shows 3186 minus 2591.9 divided by 73 minus 60. That gives you 45.7%. And that, ladies and gentlemen, is actually the answer because that is the greatest number. So your answer for the greatest average rate of change is choice 4. All I did is I just did the slope formula 4 times. That's it. Moving on to 22. Which graph represents a cosine function with no horizontal shift, an amplitude of 2, and a period of 2 pi over 3? So, we are given the amplitude is 2. We don't know what the frequency is. Now, remember what the frequency is. The frequency is the amount of times a curve repeats itself in 2 pi radians. Okay? So we're actually given the period. So the period in this case, they're telling you that one curve completes itself in 2 pi over 3 radians. So, let's go ahead and find the frequency. Now, here's the thing. The period and the frequency are always related to each other because the period, the formula for the period is 2 pi over b. Okay? So the period is 2 pi over 3 is equal to 2 pi over b. Set it equals, solve for b, and you're good to go. So cross multiply. We get, let's see here. Let me move this just because that drives my OCD nuts. So we get 2 pi b equals 6 pi. Divide by 2 pi. Divide by 2 pi. The pi's cancel. 2's cancel. We get b equals 3. There are, ladies and gentlemen, there are 3 curves on the graph that we're looking at. Okay, 1, 2, 3. That's great. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so we got to narrow it down a little bit further here, peoples. This is a sine curve. Sine curves start at the origin if there's no vertical shift. In this case, there's no vertical shift. So choices 2 and 4 show sine curves. They're wrong. Now you have to be very careful and pay attention to this. You see here? Uh-oh. They have different numbers. I just said to you before that the frequency is the amount of curves it repeats in 2 pi radians. Since there are 3 cycles on this graph and it shows 2 pi radians, your answer is choice 3 for that question. This is indicating that there's 3 curves occurring in a period of 2 pi over 3. That makes absolutely no sense. Moving on to number 23. According to a pricing website, Android phones lose 58% of their cash value over 1.5 years. Which expression can be used to estimate the value of a $300 Android phone after 1.5 years? So all you need to do is, all of these are related to the formula PERT. A of t equals PE raised to the RT. That's your PERT formula. So the initial amount is 300 E to, let's see, the rate is, all right, so, let's be careful. The rate is losing 58%. So the rate is 1 minus 0.42. So the rate, it's actually 42%. It's decreasing 42%. Times the time, which is 1.5. And that is your answer. When you multiply these two numbers, you get negative 0.87. Your answer is choice 1 for that question. All right, moving on to number 24, last one. A cardboard box manufacturing company is building boxes with length represented by x plus 1, with the width of 5 minus x, and the height of x minus 1. The volume of the boxes are modeled in the function below. Over which interval is the volume of the box changing the fastest average rate? At the fastest average rate. So again, where the slope is the steepest. We have from 1 to 2. We have from 1 to 3.5. Okay, so 1 to 3.5, like that. Then we got from 1 to 5. Okay, well, that's certainly not the answer, because it goes positive then negative. And from 0 to 3.5. All right, we need to calculate the slopes again. Annoying. Choice 1, change in y over change in x. That's going to be 9 minus 0 over 2 minus 1. Your answer is 9. Number 2, change in y over change in x. 17 minus 0 over 3.5 minus 1. Your answer is 6.8. That knocks out choice 2. Number 3 shows 0 minus 0 over 5 minus 1. Your answer is 0. Knocks out choice 3. Choice 4 is showing 17 minus negative 5 all over 3.5 minus 0. Your answer is 6.3. So therefore, your answer is choice 1. That is growing at the fastest rate. I hope that this helped you. That is the end of the multiple choice section. Make sure that you hit that subscribe button down below and visit my Patreon page. Consider becoming a patron. And visit my website at www.nysmathregentsprep.com. Both of those links are found in the description below. You can find more math content on my website in Algebra 2 and your future math subjects. And I hope to see you soon.